Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I would like to say thank you for coming in my presentation. It is great to see you all. My name is Windu Grace Suci. We are from 11 Maret University. I will present a paper about review of various sulfide electrolyte type for solid-state lithium-ion batteries. First, I will explain to you about fossil fuel energy. We know that the use of fossil fuel energy has a significant environmental impact, including global warming. Therefore, the utilization of energy sources that are environmentally friendly is very necessary. And then I will explain several types of battery application as renewable energy. We know that lithium-ion battery can be application for many devices. In this example, in electric vehicle, will be more effective and cleaner than fossil fuel. A lithium-ion battery is one of commercial battery type which is the most widely currently used source of electricity chemical energy. This issue is a liquid electrolyte is one of the primary components used in commercial lithium-ion battery construction. The liquid electrolyte in the lithium-ion battery has less safety when in use, especially at extreme temperature, where it can trigger an explosion in lithium-ion batteries. That we know what a solid-state battery is a fair safety solution in future battery because it has better stability and other advantages. However, future research is needed to obtain better energy density and then solid-state battery performance so that it can be applied to various electronic devices and electric vehicles. An overview on solid-state batteries. Solid-state batteries consist of anode and negative pole, cathode as positive pole, and solid electrolyte as the electrolyte, unlike lithium-ion battery which use a liquid electrolyte. Determining the type of cathode and anode, also the type of electrolyte, are the important thing in optimizing battery performance. Next, lithium-ion based solid-state electrolyte type. We know that solid-state electrolyte must have high ionic conductivity and then large electricity chemical stability. For general, the type of solid-state electrolyte can be divided into three categories. They are oxide type, phosphate type, and then sulfide type. Several types of solid-state electrolyte are already used in lithium-ion battery, include LATP, which include phosphate type, LLZO, which include oxide type, and then LGPS, which includes sulfide type. Sulfide-based solid electrolyte research development. The investigation of sulfide-type solid-state electrolyte started at 2005 when LPS batteries was first successfully synthesized. Then, research continued to search new material which have higher ionic conductivity. And then in 2011, research of LPSX and LMPS began and still continue nowadays. For summary, there are several types of sulfide electrolyte when the ionic conductivity value, activation energy, also electrochemical stability. From this summary, we can conclude that LGPS has the highest ionic conductivity. So LGPS is capable enough to be used as solid-state electrolyte. And then we need XRD pattern of LMPS. M refers to Ga, Sn, Se, and Al. The price of Ga is quite high and it is limited availability, means that other alternatives are needed, so that can be manufactured at a lower price. Some alternatives can in use include Sn, Se, or Al because they can maintain a similar polygon structure. Their XRD pattern shows the similar pattern of replace Ka to Sn, Se, or Al. Synthesis using Se and Al is more difficult to do because it is difficult to achieve the polygon structure wanted. From the three alternatives for replacing Ga, the using of Sn is preferable. This described in this picture. The synthesis of LSNPS show a total ionic conductivity value at 3000 Kelvin until 3.2 millisiemens per centimeter. On the other hand, instability of LSNPS electrolyte in the lithium are not become one of its disadvantages. And then conclusion and future perspective. The conclusion is number 1. Superionic conductor LGPS has the highest lithium ion conductivity at a room temperature and then excellent electricity chemical performance. The analysis that has been carried out show that the solid electrolyte type LGPS is superior to other sulfide-based solid electrolyte. And then the price of Ga required for the synthesis of LGPS is relatively expensive, so it is big consideration in the use of LGPS as a solid electrolyte. And then the future perspective. If an abundant source of Ga to keep costs down can be recovered from coal and spalarit. The solution offered for the gas hydrogen sulfide problem is the use of MO metal oxide such as ferric oxide, zinc oxide, and then bismuth oxide, which can act as hydrogen sulfide gas absorbent. And the last acknowledgement, this paper is supported by the Center of Excellence for Electrical Energy Storage plus Marat University as a provider and facilities, and then UMIAJ Lab as a provider of fund for this research. Well, thank you for your kind attention to join the presentation. Wassalamualaikum warahmatullahi wabarakatuh.